Subscribe to AmpCode and ring the notification bell to get the latest content.
We are going to continue our journey to learn data engineering. So in the last lecture we have seen all about what is Apache Spark, which is a lightning fast tool to process big data with ease, and it does that by distributing the workloads very efficiently. And since it's a pretty versatile tool, we can do all sorts of operations like machine learning algorithms, graphics, as well as real-time analytics. So here we are going to see the most popular API, or we can say capability of Apache Spark, which is like DataFrame and SQL. So last lecture we have seen all about what is a resilient distributed dataset, which is the Spark core. But recently many of the companies are majorly only dealing with the structured data where the data is stored as a row and columns. DataFrames is just a great choice to work with the structured data, and also Spark will give you the capability to work with SQL as well, so that you can submit simple SQL queries on top of the data frame to gain some meaningful insights out of that data. So without further ado, let's get into it. Okay, so let's first discuss about what is Spark DataFrame. So Spark DataFrame is nothing but a structured collection of data. So basically structure means, as you already know, it is similar to the SQL table where the data is stored as a column and rows, and data frame would have some specific schema assigned to it, which is not the case in RDD. So RDD doesn't have a strict schema assigned to it. So basically data frame is just the advancement of the RDD, and many of the organizations are using data frames only to process their structured data with ease, because working with data frame is way more simpler if we talk about syntactically as well, and if we talk about the efficiency as well. So that's why Spark data frames gained immense popularities nowadays. So if we talk about the key features of Spark data frames, the first one is the in-memory computation. So as we have already seen in the last lecture, so Spark's main advantage is in-memory processing of the data, which means that you can cache the data in memory, and also the frequently accessed data will be stored in the memory in such a way that if you have like iterative algorithm or the iterative exploration of the data, so that can go lightning fast, because all the worker nodes would not have to read the data from disk. So that data will be available in memory, so that it will reduce the input output operation of that data. So that's why Spark DataFrame also leverages the in-memory computation and makes it a very good choice to process big data. And also Spark DataFrames have the fault tolerance similar to RDD, which maintains the integrity of the data and the accuracy of the data. So when there are mission critical data like financial data, as well as the data where like the critical PI data is involved, at that time fault tolerance is a very important and critical aspect. And also the most important thing about data frames is that the compatibility. So you can create Spark data frames and work with them in many languages. You can write it in Python, you can write it in Scala, Java, R, whatever it is. So many of the developers who are coming from different languages can work with Spark data frames. So that is a huge advantage, because it gives us the flexibility to work in the language where we are proficient. So that's why Spark data frame is pretty popular choice for every data scientist out there. So because some data scientists will prefer Python, or some data scientists will prefer R over Java and Scala, and Spark DataFrame will give them the capability to write the code seamlessly and without any hassle. So that's why it has a good amount of compatibility with any languages possible. And also if we talk about the scalability, it works as similar as the RDD. In Spark DataFrame as well, all the data loads are distributed across the cluster to help them to make the process more efficient. So if you submit any data frame operation on top of a RDD and call it an action, because you already know that Spark works as a lazy evaluation. So until and unless you call an action on some data frame, then it will not get evaluated and processed. So basically when you call an action, that job is submitted across the cluster depending upon which part of the data is present on which worker node. So due to this, Spark data frames is pretty suitable for the big data applications. Now let's talk about some of the use cases of Spark data frames. The first one being data exploration. So every data analyst or data scientist can leverage Spark DataFrame for their data exploration because it gives them the capability to have the interactive Spark shell, as well as it can have like the Spark SQL, which gives them the capability to submit simple SQL queries on top of the data frames. And also there is a DataFrame API. So DataFrame has a lot of operations that you can use for getting hidden meaning out of your data. So that is the first use case. The second one is for data cleaning. So every data engineer or data scientist may need to pre-process the data before they are running some algorithms or doing some analytics on top of it. So for that purpose, Spark will provide you rich set of features, and we are going to see different operations and transformation in the upcoming topic. So due to this capability, DataFrames is a good choice to handle structured data with ease. And also, if you talk about the scalability, we already saw that since it is a distributed cluster and it works our workloads in parallel across the worker nodes, we have the large scale data processing. So when we are dealing with big data where we need instant insight into your data and take a sneak peek to get real-time information from our data, we can rely on Apache Spark because it gives us the capability to work with large-scale applications. So these are like the introductory part of Spark DataFrames.
So that's it for today. I'll see you in the next lecture.